Alright, hey y'all. Today's objective is similar figures. Similar figures are the same shape but different sizes. Congruent figures are the same shape and the same size, but similar figures are the same shape but we're going to have different sizes. And we're going to focus on triangles. So there's this theorem called the angle-angle theorem. Two angles. Angle-angle theorem. And what that states is that if you have two triangles that have two congruent angles, that means they have to be similar. If two angles are congruent, then the triangles must be similar. So let's take these two triangles. Right now, we don't know anything about them except for we have an angle that's 33 and 67 and another angle that's 33 and 67. We know that the interior angles add up to be 180. So if we were to add these together and subtract that from 180, we would get this third angle, and they would be the same. So we know if two angles are congruent, 33 to 33 and 67 to 67, that these triangles are similar. And there's two important things that you need to know about similar triangles. The angles are congruent, we already know that. And sides are proportional, so we're going to be working with proportions again. So here are some examples. Determine if the triangles are similar. So I've given you some triangles, and I don't know if they're similar, so let me show you how to determine if they are similar. These, we do not have any angles. It'd be really easy to look at the angles. We don't have any angles, so we're going to have to look at the sides. Are they proportional? So we look at first this, AB and DE. So we're going to start making a ratio, 25 to 15. When we do that ratio, we can simplify. We divide both sides by 5, we get 5 over 3. So I divided the top by 5 and divided the bottom by 5. So whenever you're writing ratios, you want to simplify. Then let's look at this line. BC is 20 and EF is 12. Alright, so 12 and 20. 5 doesn't go into 12, so let's simplify by something else. If we simplify, 4 will go into both of them, so let's divide by 4. 20 divided by 4 is 5, and 12 divided by 4 is 3. So right now, our ratios are the same, so it's looking like they might be similar. Let's check the third ratio. 30 over 18. We need to simplify that ratio, so let's see, what will go into 30 and 18? 6. Let's divide the top by 6 and we get 5, and 18 divided by 6 and we get 3. So these are similar because their ratios are all the same. 5 over 3 and 5 over 3 and 5 over 3. Now example 2, we have two triangles. We have a big triangle, ABC, and we have a small triangle, DBE. Are these triangles similar? Well, first let's look at the angles. Angle B is the same angle in both triangles, in the big triangle and the small triangle. So we know they have one angle in common. Now let's look at these two right here. D and A. If I were to extend these lines, you would hopefully see that I have parallel lines cut by a transversal. So this angle and this angle are corresponding, which means they are congruent. We know they're corresponding, and that means they're congruent. So right now I have two angles that are the same. Angle A and D are congruent, and then angle B is congruent to itself. The same thing means, you can apply the same thing over here. E and C are corresponding, which means they're congruent. So these qualify by the angle-angle theorem, and the answer is yes. They are congruent because I have two angles that are congruent. These are similar. Sorry, these are similar because I have two angles that are congruent. Find the missing length. Alright, I have two triangles that are similar, and I need to find this missing length. To find a missing length, you're going to set up a proportion, and to me, it's just easier to start with x. And then what I think to myself is, does x come from the big or the small shape? X comes from the small shape, so I'm just going to put a little s on top. We need to find what corresponds to x. So the line that corresponds to x is this line right here. So we're going to put 24 on bottom. The reason I need to put a little s is to help remind me. I need to start with the small shape. What's the other number from the small shape? 12. And then what corresponds to 12 is 72. Once I have my proportion, I can cross multiply. So 72 times x is 72x. 24 times 12 is 288. Divide both sides by 72, and we get 4. 24 times 12. Oh yeah, we get 4. Sorry. So that means this is 4, which would make sense. If 72 is bigger than 24, then 12 would be bigger than 4. Example number 2. I have an x right here, so I'm going to set up my proportion. I'm going to start with x. X comes from the big, so I want to keep my big shape on top. X is this vertical line, so I need to find the value that corresponds, and that would be 5. Another number from the big triangle would be 110, and 110 corresponds to 10. I would set up my proportion and cross multiply. X times 10 is 10x, which 110 times 5 is 550. And x equals 550 divided by 10. X equals 55. No. $110 times 5. X equals 55. Okay. Sorry. That would be times 11 times 11. Okay. X equals 55. I kept thinking I was typing something wrong. So, real world. When are we going to need this in the real world? Find the height of the flagpole if a 5-foot girl has a 10-foot shadow and the flagpole has a 30-foot shadow. So I've already drawn the picture for you. Find the height of the flagpole. So we're looking for how tall the flagpole is. If a 5-foot girl has a 10-foot shadow, the shadow's on the ground, and the flagpole has a 30-foot shadow. So if you notice, we're going to set up a picture and make similar right triangles. We know these triangles are similar because they have an angle theorem. They both have a 90-degree angle, and then when the sun is shining down, the other two angles are going to be congruent. So we're going to set up a proportion. X over 5 equals 30 over 10. You can cross multiply and then divide, or maybe you see the pattern. 5 times 2 is 10, so x times 2 is 30, which means x has to be 15. So the flagpole would be 15 feet. So this last one I want you to do on your own. A building casts a 96-foot shadow at the same time a 4-foot boy casts an 8-foot shadow. How tall is the building? I want you to work this one on your own, and we will go over it in class.